Well, ho 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 and Merry Christmas. I thought we would finish our year out with a bit of BGP, sprinkle in a little bit of OSPF, and we'll share some routes between a couple of autonomous systems. So let's jump into the lab and let's close out 2025. And here's our lab for today's video. What we are going to do here is we're going to use some of our OSPF skills that we've learned. In our AS200, our autonomous system, which is ours, we're going to create a OSPF neighbor relationship between our two routers, similar to what we've done before. And then we're going to create an iBGP peering between the two loopbacks that we're going to be advertising to each other via OSPF. And then from there, we're going to have each of our routers create an external BGP peering to an external AS, and they're going to receive a route from each of these external ASs, and we're going to see that show up within our AS200's routing table. And we're going to verify that each of our routers can reach AS300 and AS100. So this is just a very simple overview of configuring two dynamic routing protocols. We're going to look at iBGP and eBGP and a little bit of OSPF. We're not going to worry too much in this video about the security of it, about filtering and what we're going to accept and not accept and imports. That'll be in the new year. But for now, we're just going to close the year out with a simple configuration to show how we can configure iBGP within our own AS and how we peer to another AS to receive or to advertise our route to them. So we'll start within AS200 as that's our area, and we're going to start with this router here, router 2. Hopefully, if I pop myself just about there, we'll be able to see the interfaces. So freshly booted, no config on here. And remember, if you haven't already, we're nearly at 500 subscribers. So if you could smash that like and subscribe button, it'd be greatly appreciated. Every subscribe on the channel helps me know that the videos are being watched and people are enjoying them. So it'd be greatly appreciated if you could do that. And it's fantastic. It doesn't cost you anything. It's all you need to do, just so that I know that people are enjoying the content. Right, so let's get into our configuration mode. Let's start by the basics of setting our RTR-2, so we set our host name. So we know that router 2 is going to have a loopback address of 2221, so let's start there. So int L0, description is going to be our loopback. Our IP address is going to be 2.2.2.1 and 255.255.255.255. There we go. That is our loopback interface configured. Let's look at our other interface that would need configuring. I see Sniff has decided to plod up and down just as I've hit the record button. We're going to do G0/1, which is 10.0.2.0/30. Okay, so int G0/1. Description, link to RTR3. IP address. It's going to be 10.0.2. .1. Let's use .1. 255.255.255.252. So /30. No shut. So we've configured our loopback and we've configured our interface here. Next, we're going to want to configure OSPF because we're going to want to advertise our loopback to router 3. And obviously router 3 is going to want to be able to advertise its loopback to us. So we're going to need to set up some OSPF. So let's do that like we've done in a previous video. Let's do a router. Let's come out of interface mode first. We will go router OSPF. Let's do 2025 for the year. Default passive interface. passive interface default is the one I'm looking for. And we will do no passive interface for G0/1. Because obviously we're not going to be using OSPF to talk to this external peer. We're going to be using BGP to receive routes from them. We're also then not going to be inputting those routes within our OSPF table in AS200. We're going to be using iBGP to carry those routes to our peers. So no passive interface for that. Our router ID is going to be our loopback of 2.2.2.1. And I like to do it on the interface level. So in L0, IP OSPF 2025 area 0 int G0/1 IP OSPF 2025 area 0 IP OSPF network type, as we've seen before, because this is a point-to-point, we're going to use point-to-point. And we will no shut that. So save that config. So we've done this pretty much before. We've done configuring interfaces, we've configured OSPF. So nothing new so far. So we've got our loopback. We've got our interface to our internal peer. We are passive, all interfaces are passive apart from this one towards our internal, and we are advertising this network and our loopback. So we should now be able to then go and jump onto router 3. And what we will do now is we will configure the same and check that we can see the loopbacks. Because with iBGP, we're mainly wanting to be doing our peering between our loopback interfaces. So you can kind of think of, again, similar to how we've done with VXLAN and stuff like that. It's similar that we're using OSPF as like an underlay to carry the information about links between routers. And then we're using the BGP protocol to carry our internet routes or our customer routes or our service routes that we want for our external providers or our peerings. So we're using 2 layers of routing. We're using one for our underlay management that shows where all of our management IP addresses are, where our loopback addressing is, etc. And all of our links between our routers are advertised within that so that routers know where each and every other device is or what the map of the network is. And then we use BGP on top of that to maintain the fact that then BGP can then stay up and operational because the underlying OSPF layer can make the changes when the network topology changes. But BGP will always have reachability to the addressing on the top layer, if that makes sense. So again, host name, this is RTR3. Then do our loopback, 2.2.2.2. Description is our loopback. And what we're going to do is our next interface, which is int G0/1. The IP address here is 10.0.2.2/30 address. Now we will do our router OSPF passive interface is going to be default. Our router ID is 2.2.2.2 and no passive interface for G0/1 because that's the other router here that we want to make sure that we have an OSPF neighbor relationship with. So we can now exit that. We go back into our interfaces. So in L0, IP OSPF 2025 area 0 G0/1. It's going to be the same. And IP OSPF network type will be point to point. Okay, and there we go. We can see we've already got our neighbor relationship up. So we've successfully configured OSPF. So let's do a show IP OSPF neighbors. As we know, this is how we can see. So we see we've got a full state. So we know that we've got a correct neighbor relationship now with 2.2.2.1. So now we do a show IP route OSPF, we'll filter it. We should see that we can see the loopback address of that router successfully in our routing table being advertised to us via OSPF. That is all good. That is exactly what we want to see. Next, we've got this major network here that is part of our AS. So we're going to advertise that at our borders, but we're also going to create now an iBGP peering between these two routers, and we're going to do it between the loopback addresses. So let's start on router 2 again. And we're going to go router BGP, and our AS number is 200. Our BGP router ID is going to be 2.2.2.1. Pretty standard. We're going to have a neighbor relationship with 2.2.2.2. The remote AS is going to be 200. It's the same. And I'm going to want to source that from our loopback address. So the update source is going to be from our L0. So that should be enough to do that. Next, we're going to want to advertise our main network. So this is how we advertise a network into OSPF. We're going to advertise 200.0.0.0 mask 255.255. So we're advertising a /16. So that's enough for that. Let's do a show run. So we can see we have added this BGP configuration. We have set our network that we're going to be advertising. Obviously, it's not going to matter too much here, but it's what we're going to be advertising out to our externals. And now what we're going to do is we will do a similar configuration on this side, and we will make our neighbor 2.2.2.1 and update it from our loopback, and we should see an iBGP session come up. So let's jump over to router 3. Okay, router BGP 200, which is our AS. Our BGP router ID is 2.2.2.2. Our network that we are advertising is 200.0.0.0. Mask is 255.255.0.0. And our neighbor is going to be 2.2.2.1. The remote AS is 200, our same. So it's because we were within the same AS and the same remote AS, it's an iBGP. And we'll see that in a minute when we look at the neighbors. We're going to change it so our update source is going to be from our L0. So that should be enough to get our session up. Let's do a show IP BGP neighbor. And there we can see that we have a BGP neighbor 2221. The remote AS is 200, and it says here internal link. So this is an iBGP connection between the two. And we're doing it via these two loopback interfaces, because if we say we had another link or another path to this router 2, because we're doing it over the loopback addresses, the OSPF layer underneath can change and adjust based on the network topology if an interface goes up or down. But because we're peering between the loopbacks, the loopback interface will always be reachable once the change has happened underneath. So you're less likely to see the session drop because you're doing it between the loopback interfaces. The key note here is to see that the state is established. Seeing that lets you know that it's up and it's working. So let's have a quick look at our routing table. We can see that we have no routes other than our OSPF routes in our table, which at the moment is fine. And we'll change that in a minute once we start to advertise our networks. Let's jump back over to router 2, show IP BGP neighbor. And we can see, again, we have a session with 222, and it's an internal session, which is good. Next, let's start on router 2, and we're going to configure this external BGP peering now to our external provider. So let's jump onto router 1 first and set him up. So we're going to configure this side, and we're going to advertise 100.0.0.0/16 into AS200. I'll also put an additional loopback interface on this router, and we'll use 100.0.1.1/24, and we'll test that we have reachability. So host name is RTR1. We will give this a loopback as well. The IP address is 1.1.1.1. And we're not going to do any OSPF on this side. So that's it for the loopback interface. Int G0/0. The IP address is going to be 10.0.1.1. It's a /30. No shut. We'll bring it up. And now we will configure our router. BGP AS is 100. Now BGP router ID is 1.1.1.1. The network that we are going to be advertising is 100.0.0.0. The mask is 255.255. So this is a /16 that we're advertising. Our neighbor relationship is going to be different. This time we're doing it between the interfaces because this isn't a single external relationship here. So the neighbor is going to be 10.0.1.2. And the remote AS is going to be AS200. Now, because we also are the border router and we don't have any networks or any interfaces inside this network here, you'll see that when I bring this up, you won't see this network advertised. So let's bring the peering up first, and then I'll show you how we advertise this network when we don't have any interfaces or any interfaces within that border router within this network subnet. So let's jump back over to router 2. Let's configure our interface that's going over to AS100. So description, link to AS100. IP address is 10.0.1.2. No shut. Now let's configure a router, BGP, AS200 for us. And we're going to configure a neighbor relationship to 10.0.1.1. And the remote AS is going to be 100. And again, we can see that router 1 has got a neighbor relationship. Show IP BGP neighbor. So you can see router 1 has a neighbor relationship with 10.0.1.2, this interface here in AS200, and the remote AS is AS200, and we can see now this is an external BGP session. We can see its state is established, so we know that it's up and working, and we can see that there is its uptime. We can also see information about advertised prefixes, etc., the number that is sent and the number that is received, and we can see that at the moment there's nothing. So now if we do a show IP route, you can see again AS100 hasn't received any route, but we have a session. So what's going on? Now this network, this router over here, doesn't have any interfaces in any of the 100.0.0/16 networks. So it's not going to have the ability to advertise, the protocol is not going to advertise that. We could put an interface in that one of those networks. So if we go int L1 and we put the IP address here as 100.0.1.1, make that a /24. Now, if we come over to router 2, do we see anything different? We have a look. We see there's no prefixes that have been sent or received between that session. Show IP route. You can see that we haven't received any, because if we do a show run, advertising their whole AS towards another autonomous system, so that that autonomous system knows how to reach that allocated pool of IP addresses that that ISP may be using. See, this /16 may be broken down across a whole country for that ISP, and they may be using subnets out of that /16 for certain areas of the network. And then at the edge, we're not going to have any of those interfaces within that network. So we need to put in place what we call a pull-up. So what I'm going to do on router 1 is I'm going to do an IP route, and I'm going to route 100, and I'm going to route the /16. I'm going to route it to null 0. I'm going to give it a name of pull-up. Now, what have I done there? What I've done is I've made BGP aware that this network, that if we do a show run under the BGP section, this network here, where are you? There we go. This network is up. It's in the table. So you should now be able to advertise this network to our peers. And the reason we want to do it this way is that if we go over to router 2 and we now look at the routes, we can see, there we go. We can see that we've got an external BGP route to this 100/16. Now, AS100 controls that whole subnet. So anything to do with that subnet is going to be in here. So if they were to start advertising all of these small little subnets out of their allocation to me, my table on router 2 is going to get bigger and bigger and bigger, because I'm having to have 100.0.1/24, 100.0.2/24, because I'm advertising all of these little tiny individual networks over, which is inefficient. So on the border here, we normally advertise a large block to the other AS, and then that way, even if downstream, if we stop advertising 100.0.10.0/24, one of our customers inside this AS is using that subnet. If we stop announcing that one, that customer stops using that pool, it doesn't matter. There doesn't have to be an update between these two peers. They only need to know that anything to do with that network, it goes here. And to test that on router 2, if I do a ping, I'll need to advertise a path back. No, I won't, because we can do it from we can source it from this interface here. So if I ping 100.0.1.1, and I source that from 10.0.1.2, you can see that I can ping that network because it's in the routing table and it knows how to get there. So let's go and have a look at router 3 briefly before we move on. So if we show IP route on router 3, you can see that we don't have that network. It's not in our table. So now we need to make some changes so that that network gets advertised to us over here. So you can see if we look at router 3, now I've remembered the command show BGP IP unicast topology. You can see it has it there, but you see the next hop it says is 10.0.1.1. But you can see we don't have in our routing table a route to 10.0.1.1. So we're not going to put that route into our network. So the way that we do this is that we're going to tell the border router to make itself the hop for any network, for any networks that it receives from an external peer. So if we jump on a router 2 and we go back into our BGP and we go to our neighbor 2.2.2.2, we're going to say our updates, not our update source. Let's say our next hop is self. So what we're doing there is that we're saying, hey, any external routes that we learn about, i.e. our connection to AS100, instead of advertising it with this 10.0.1.1, which is this link here, which this router has no clue about, it's going to advertise, it's going to learn the route, and then it's going to re-advertise it to its internal BGP peers and update its route source as its IP address, so that any other internal BGP peer will then say, hey, if I need to reach 10.100.00/16, I'm going to send it to router 2. So now if we jump over the router 3 again, and we do this show BGP unicast, we can see that the next hop has now changed to 2.2.2.1. So you can see that now we do in our routing table have a route to that IP address. So now BGP will allow that external network to be put into our table. So now we need to advertise our networks back to them. So if we jump over to router 1 and we do a show IP route, we can see that we're not receiving anything. If we do a show a BGP IPv4 unicast, okay, we can see that we're not receiving anything from that neighbor. Okay, so now on router 2, we're going to do the same thing. We're going to put a pull up in place for our network that we're using for our customers and all of our data, not our underlay network. So IP route 200.0.0.0 255.255.0.0, and we're going to route that to a null 0, and again we're going to name that as our pull-up route, and I'm going to put a interface L1, and I'm going to say we've got 200.0.1.1 there, and then I'm going to come over to router 3 and I'm going to advertise another loopback network down here. I'm going to advertise int L1 IP address 200.0.2.1. So now if I come over to router 1, I have a look again, I can see now I am receiving this network for 200./16 coming from this border. So now let's check from router 2. We're going to ping 100.0.1.1 with the source address of L1. We can see that we're pinging it with our 200 IP address. Let's jump over to router 3. So what we will do is on router 3, because this is also going to be a border, we already have that /16. And then what I'm going to do is I'm going to put a IP route 200.0.0. I'm going to route that to null 0. Name that as a pull-up router. BGP 200 network. Let's be more specific. 200.0.2.0 mask /24. Then we'll look at our routing table on router 2. There we go. We can see that we've got the /24 received. If we go over to router 1, there we go. Because we're not doing any filtering, we can see that this /24 is shown up. So now they're receiving the /16 and the /24. Now to stop this, we would in future put a filter on here and say that we only want to advertise the /16 and nothing else. But at the moment, that should now get us reachability from router 3. There we go. Has now got router 3, has now got reachability over to AS100. So we show IP route here as well. You see that we have received the route for that network. Router 2 has got the /24 in its table. Obviously, it's got its own /24 that we've got allocated on an interface. And then it's receiving the 100/16 from AS100. So now we're going to do a similar setup from router 3 to router 4. We're going to configure another external BGP peering here. And then we're going to take a look at the table again. So on router 3, we will just do the interface first. And then I think what we can do is we can put some filters in so that when we're talking to our external ones, we only want to advertise the larger one. We don't want to advertise our smaller /24s to our externals. So that's what am I doing? Int G0/0. IP address is 10.0.3.1 /24 /30, so 254. No shut. And again, as we're going to be receiving an external route, we're going to change our neighbor relationship to our iBGP, and we're going to update. We're going to change it so that we're the next hop. So router BGP 200 neighbor 2.2.2.1, and our next hop will be self. And whilst we're in here, we might as well do our neighbor is going to be 10.0.3.2, and the remote AS is going to be 300. We'll save that. Now let's jump on to router 4, sorry. Let's set him up so that he receives some routes. And then we'll put some filters in place and make sure that to our externals, we are only advertising our larger block, our aggregate, rather than advertising all of our /24s. So we'll set our host name, set our loopback IP address, it's going to be 3.3.3.3. Int G0/0. IP address is going to be, what did we say it was? It was 10.0.3.2. no shut. So that's our two interfaces. We will create our L1 interface and give it an IP address of 103.0.1.1. And that's one of the first addresses out of this /16 block. We will do our pull up. So IP root 103.0.0.0. Send that to null 0, name it as a pull up. And now we will configure our router BGP AS is 300. Our BGP router ID is 3.3.3.3. Our network that we're going to be advertising is 103.0.0.0. The mask is at 255.255/16. We're going to have an external peering with neighbor 10.0.3.1, and the remote AS number is going to be 200, sorry. And we will save that. And we can already see that we have our adjacency up. So if we show IP and BGP neighbor, we can see that AS300 has a neighbor relationship to AS200, an external. It's established. We can see that it's received 3 routes and it's sent 1 route. And we can see in its routing table, it has learnt about the 100/16. It's learnt how to reach AS100 through AS200. And sometimes you might not want that. It's like, if you're a private company, you may not want someone else that you're peering with transiting your network to reach another network. And that's why later when we put the filters on, that's what allows you to filter what you're receiving and what you're sending out to your BGP peers, because you don't just want to become a transit spot for other ASs. So we can see that at the moment, AS300 has learnt about AS100 via us, and it has also received our /16 and that /24 that we're using on one of our other routers here, which is not really what we want to do. We want to only be advertising outbound our /16, which is what we will do in a minute. So now if we jump over to router 3 back in AS200, and we do the same, we do a show IP route, we can see that we have learned about 103 and obviously 100 from our other peer. If we check router 2, we can see that it has learned about 103, and you see the hop has changed to the loopback of this one, which is what we want, because we're re-advertising networks that we learn about as ourselves to our internal peers, so that any other peers know how to reach that network. It looks like I forgot to advertise that /24 from that one over to router 3. So now if we look, router 3 should have in its table that other network should now be being advertised. Yep, so 200.1/24 is being advertised from here to here, and we're advertising 200.2 to there. So let's add that onto our thing so we don't get so let's just duplicate that. So we're advertising on 200.0.1.1/24 on L1. being advertised on this router. And we are advertising from this one to 200.0.2.1/24. So we've got these two networks out of our network being advertised here. So they're on the iBGP, we're seeing both of the /24s, and then outbound, we're also advertising our /16. So now if we check over here, we should see we have our 200/16, and then we have the 2/24s being advertised. But like I said, we don't want to advertise these ones outside of our area. We only want to advertise this one. So next we'll put a filter in place so that we filter what we're sending outbound to external ASs. Like I said, on our internal one between 3 and 2, do a show IP route BGP. You can see that we want to know about our customer routes and routes that we've learned from outside, but we don't want to advertise those ones here. So we've learned about this one via BGP, and we've learned about this one via BGP, and we've learned about this one via BGP, which is all good. So next we're going to put a filter towards our customers to say, hey, we're only going to be advertising the aggregate to you, so that when we look at our look at our routing tables on our remote ASs, we can see that we're not filling them up with every other /24. They only need to know about this to reach this, because once they get in here, this one already has a route to this network. So let's just create that now. So if we look, currently router 1 is receiving not only our aggregate, it's also receiving our smaller /24s, and we want to stop that. So let's start by creating a filter here on R2 to filter outbound what we're sending. So we'll jump onto router 2. And we're going to create an IP prefix list, and we'll call it the AGG-only. And we will permit our subnet, which was 200.0.0.0, and it was a /16. So we do our root map and advert AGG permit 10. So that gives us our root map. We will match our on IP address our prefix list, which we called AGG-only, I think is what we called it. And then we will put a deny directly underneath it. And then we'll jump into our router BGP 200, and we will go to our neighbor, which was 10.0.1.1, and we will route map, and we will use our advert-agg out. So that should now filter what we're sending to router 2. So if we have a quick look over here now and we do a show IP route, clear our session to 200. Let's check again. There we go. So now the session has restarted. You can see that we are now only receiving the aggregate from here to here. So we're no longer receiving the all of the /24s, which is what we want. So now if we look over at router 4, which is in AS200, you can see that we're still receiving these, and we're still receiving this route about AS100, which we don't want, because AS300 could peer with AS100 directly if they want to. We don't want them transiting through to us to reach AS100. So we only want to advertise our networks to our peers, unless they're paying us for transit. And I forgot to apply it. So config T, router, BGP 200, neighbor is 10.0.3.2, and the route map was, what was it called again? Advert AGG. Advert -AGG out. So now let's just clear that BGP session again. There we go. We can see now that AS300 is now only receiving our aggregate. So we're going to test from here to make sure that we can ping 200.0.1.1. And I should probably source that from an address that it is reachable from. So that would be from source L1. There we go. So 103 network can reach the 201 network. Let's do the other one, which was 200.2.1. Can reach that. So there we go. So our remote AS can reach our two networks that are being advertised. We're advertising our aggregate via BGP. Our underlay is using OSPF between our peers. The other thing that we can also do is if we know for security, say on router 4, this one over here, AS300, at the moment it's receiving anything that's advertised. So they could also have a similar route map. So let's do an IP prefix list again. We'll give it a name, AS200, BGP, AS300, router, BGP 300, and our neighbor, which was 10.0.3.1, route map, AS200, inbound. So now we are saying outside this AS, we're protecting ourselves, saying, hey, yeah, we have a peering with you over in AS200. We are only expecting this subnet from you. If you try and advertise something else to us, we're not going to accept it. And you have to be that way with BGP. You have to filter on your inbound and on your outbound. You can see that we're still receiving the route perfectly fine because it is being filtered. So if we do show IP and BGP, there we go. We can see that we're receiving this one from our remote peer in AS200. There's the path, AS200. Perfect. And now for our final trick, I've now added a secondary link between our two internal peers. And we're going to bring that up, advertise that into OSPF. And so that each router will then have two paths to the loopbacks. And we'll demonstrate that we can then disconnect, shut down any one of these interfaces at a time, and each node will still be able to reach each other's iBGP peer loopback address, and the sessions will stay online. So there'll be no BGP flapping that we need to worry about. So let's jump on to router 2 and router 3. That came up quick. So let's do int g0/2, configuration mode int g0/2. IP address will be 10.0.4.1. IP OSPF network type, point to point. Network would be 2025, I think we said it was. Area 0. Area 0. We shut. Router OSPF 2025. No passive interface G0/2. Jump over to router 3. In G0/2. IP address 10.0.4.2/30. IP OSPF network is point to point. IP OSPF 2025 area 0. We will no shut that. And then again, router OSPF 2025, no passive G0/2. Show IP OSPF neighbors. We can see we have a neighbor relationship to the same peer twice over 2 connections. Show IP route. You can see we have 2 paths via Ethernet 01 and Ethernet 02 to reach the loopback address of this device, and the same will be on this device. Show IP route. It has 2 paths to reach 222, which is good because for the underlay network, that now means when BGP is peering between these two, if any one of these interfaces goes down, the iBGP session will stay up and won't have to be renegotiated because OSPF will say, hey, you can now reach that via this interface. Or when it comes back up, it will say you can reach it via this interface. So this is how we build the redundancy on the underlay level. So now we've pretty much built what we set out to build, which was to have our 3 ASs, have AS200, have an external peering via 2 gateways to 2 external peers, for them to only advertise their aggregate address, the /16, to the external peers, to receive an external peer address, and to then re-advertise that via iBGP to their other respected routers. So hopefully that made sense, and you found it interesting. Jump over the talking screen. This will be the last video of 2025 as I wind down now for the Christmas period. Next year we will build on this some more. We'll finish up our OSPF video. We need to go through some configuring of authentication so that you can authenticate the and secure the connectivity between your OSPF neighbors. We also need to look at manipulating the path using cost or bandwidth so that you can manipulate which paths are used or installed by default into the routing table for OSPF. And then we'll move on to things like BGP as well, seeing as we haven't fully covered BGP, and we will create a bigger BGP lab where we will share more routes and we will do security on BGP as well. So this was just a brief overview just to get you in the mood for what's coming up in the new year. Thank you very much for everyone who subscribed in 2025. We're, like I said at the start of the video, we're nearly at 500. It'll be amazing if we could reach the 500 mark before the new year. And I look forward to seeing you in the new year. I hope you all have a very Merry Christmas and a Happy New Year, and I'll see you then.